Now, for real this time. Okay, so if you're using an IDE like PyCharm, or Spider, or whatever, there's a lot of IDEs out there that you could use. IDE is just the big word to describe the integrated development environment, like this. Okay? So this is an IDE. There's a bunch out there. We were using Google Colab, which is kind of like an IDE, but it's online. But the cool thing about Colab is all the code runs on a computer somewhere else in the world. Here, when I'm running it, like I would be running these programs on this computer. So there's one of the differences. And as I start writing bigger and bigger programs, as the programs get more and more complex, I might want to shift towards something like an IDE because it's got a lot of bells and whistles that make things a little easier for me as I go. Raise your hand if you're in 162. Okay, if you're really high. Why, where? All right, for those of you not, just take 162. But in 162, we'll be primarily using an IDE. It's called IntelliJ is the one we'll use. It's made by the same people that make PyCharm, so they're similar. But anyways, if we've got some code like this, okay? I'm going to go put it here, and this, of course, should not be here. Return cur max. Oh, no, that should be there. My mistake. Okay. So this code is broken. So what this is supposed to do is do a linear search, like we've seen countless times, but the only thing that's special about it is, while doing it, we're going to keep track of the biggest index and the biggest value. The index of where the biggest value is. So if we look really quickly at this code, it might not look too bad, right? Like, okay, current max index is 0, and the current biggest thing we've seen so far is the thing at index 0. Okay, great. We just set those as the starting values. Start the counter at 0. Well, the counter is less than the length of the list. If the list at C is bigger than cur max, update the current max and increment the cur max index and return at the end, cur max index. Okay, so quick look, doesn't look like there's anything too wrong with it. But if I call this function, let's say, so the biggest number is 9, and that's at index 0, 1, 2, 3, 4. So if this is working correctly, I should be able to say, okay. And then I'll also print out the list at there. So what this function should do, is supposed to do, is find the largest index, find the index of the largest element in the list, give it back to me. So I'm going to print out the index, and I'm also going to print out what's at that index from the list, right? So if this is working correctly, I should hit run. I should see that it gives me back 0, 1, 2, 3, 4, the 9. So index 4, and then if I print out the list at index 4, I should get 9. So let's see what happens. We'll run this. We see 3 and 7. 0, 1, 2, 3, and 7. Well, the 7 is at index 3, but that's clearly not correct. So there's something wrong with this code. So I'm going to make use of the debugger. There are a number of things I can do with the debugger. And let's have a look at the course content, because I think I'd go through steps on what to look for. Okay, so the first thing I'm going to do is I'm going to put what I call a breakpoint. Every IDE is going to be a little different on how you do this, but the idea is I'm going to set a breakpoint. And that's a fancy word that just means when I run this in the debugger, when I run this code, I want you to run, but as soon as you get to this line of code, I want you to pause. So then I can have a look at what's going on. And then when I want you to continue, I can say, okay, continue. So given where it is, I'm basically doing it at the end of each iteration of this loop, which is probably a good spot for it. So I'm going to now hit debug. It's this button up here. It's really tiny. But if I hit that, okay, great. So I hit debug, and we are currently on this line of code. And it actually halts like right before that line of code. So it actually hasn't run that line of code yet. So it's kind of like it's between line 9 and 10. And what do we see down here? Well, we see a list is 16379425671, which is conveniently the list which we pass to the function, which of course is calling it a list. And look, it kind of added these like fake comments. See how it says a list, and it actually says what the values are. Cur max is 1. Cur max index is 0. Well, yeah, that makes sense because we just started, we see the 1, and that's where we are. Counter is 0. So it actually is telling us what the values are at this point in the execution of the code. So now I want to resume. So there's a little button here for resume. It's F9. So resume. It's going to basically do one iteration. So we see C is now 1. So C is 1, cur max value is 6, and cur max index is 1. Well, that looks good so far, right? Because we came across a value 6. 6 is bigger than 1, so we update the counter and the variable keeping track. Or pardon me, we update the variable keeping track of the maximum value we've seen so far, and the variable keeping track of where it is. So far so good. So when we hit run, we should see nothing change except C for the next one, because the next value is 3. And if everything's working correctly, if I let it run one more step, there should be no change, because 3 is not bigger than 6. So let's make sure that happens. Okay, so only C changed. Cool. And you'll see there's kind of like a color coding going on. The red, they didn't change. The blue, they changed. So C is now 2, and we haven't updated it. Then we see it should be 7. And you know, based on what I saw when I tried to run this program before, and I saw something wrong, I'm under the impression I might see something fishy here, right? So if everything's working correctly, 7 is bigger than 6. So cur max should be updated to 7. And we should see 0, 1, 2, 3. We should see cur max index become 3 if everything's working correctly. Do you agree? Are there any questions? Yes. Or you agree. Okay, cool. So let's see. Okay, so the counter increased. Cur max is 7, and the cur max index is 2. But it should be 3. Huh. So something funny is going on with cur max index. Let's see what happens if we do it again. 9 should be the cur max. Yeah, okay, so cur max became 9, but now cur max index became 3? 0, 1, 2, we're like behind now. So at this point, I'm going to suspect that my issue is probably where cur max index is. So let's have a look at the code where we modify cur max index. Can anyone see the issue? Raise your hand if you do, really high. I want to see. Look at the code, take your time, see if you can find it. Don't yell it out. Take 10 seconds, look at it, see if you see the issue. All right, really high, I want to see if you see the issue. So it looks like the problem I've got is Kermax index. When I'm updating it, I should be updating it with what the index is of the current max value. But what am I doing instead? I'm just adding 1 to the index, which doesn't make any sense. Why would I add 1 to the index? In fact, let me show you with a more extreme example. 1, 1, 1, 1, 1, 1, 1, 2. Okay, I'm going to stop this round of debugging, and I'm going to run again. Okay, so, 1, 1, 1, 1, 1, 2, Kermax is 1, Kermax index is 0. Resume, 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 resume. So nothing's changing because 1 is not bigger than 1, so whatever, we skip it. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, it was on this iteration where something funny happened. What did the code say? If Kermax at index C is bigger than the current, or pardon me, if A-list at index C is bigger than the biggest thing I've seen so far, that means it's bigger than the biggest thing I've seen so far, meaning that it is now the biggest thing I've seen so far. So if that's the case, I'll update what Kermax is, which is A-list at index C. But Kermax index started at 0. Nothing changed until this condition was hit. We increment Kermax counter to 1, but the current max is actually at index 8. So the fix to this is not this, it's just this. It needs to be set to the index of where the biggest thing I've seen so far is. So let's stop. Let's run this again. Actually, let's go back to the okay, let's go back here. And I'm just going to run it this time. No need to run the debugger because I suspect, look at that, index 4, value is 9. Great. Are there any questions about what we just saw? Because what did I show you? 1, we can set breakpoints. 2, we can tell it to debug, which means run, but stop whenever you hit a breakpoint. I can resume execution after it stops. And all the while, I can keep track of the value of the variables as we go. Which I'm sure, as you can imagine, if you're doing this pencil paper, if you've got 4 variables, that's one thing. But if you've got 10 variables changing, that's going to get pretty chaotic. So yeah, there we go. This is just telling you everything I just watched. Now, another really cool thing is, by default, when I did debug, it was telling me the values of these variables. It was just telling me all the variables that were there and what was changing. But I may not care about some of them. So I could actually, oh, come on. No, here we go. I can add very specific things I care about. Because maybe this is full of like a bunch of things, but there's so much information there that it's just chaotic to me. It's hard for me to keep track of. Nope. C. There. So if I only really cared about one thing here, I can specify the one thing I care about. Or 1 or 2 things. Because as you can imagine, if there's a lot here and there's all this changing, it can be kind of hard to see what's going on. So I can just watch specific ones. And another thing that's kind of cool is you can actually ask specific questions. Like, I'm not only just watching a variable, I can watch some calculation. like again, if it's sitting near the back, it's going to be hard to see. But if I'm not watching the variable A-list or cur max there, no. What I'm watching is A-list at index C greater than cur max? And it tells me if it's true or false. And if we step through this, we can see how this will change. So false, false, false. What? Oh, I guess I'll have to stop it here because it's changing so fast. Pardon me. Let me stop and restart that. Okay. So it's false. Now it's true. False, true, true, false, 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 and so on. So I can also watch expressions, the result of an expression if I want, which is pretty cool. I know we were doing this before where we just threw these in prints, right? I realized that. I realized that if I wasn't using a debugger, and realistically this is probably what I would have done if I was trying to debug this on my own. I wouldn't have used a debugger. I probably would have said like, okay, print C cur max, and if cur max, nope, cur max at index C is greater than, nope, that should be A-list. Right? I could have easily just done this, right? And then I view the output, great. But the debugger kind of just, keeps track of that for me, which is handy. Okay, any questions so far? All right. So yeah, we just did that. Yeah. Adding expressions to the, we just did that. Stepping through code one line at a time. So here's the last really, well, let me make sure it's the last really big thing I wanted to show you. Okay, no, there's one more thing I want to show you after that. So, great. I set a breakpoint, but maybe what I want to do is, like, what if I wanted to stop on every line of code? Should I add a breakpoint to every line of code? Just resume. You could, but a handy little feature is if I start my function here, I'll say debug. Okay, there we go. I've got all these values. I've got some buttons up here. Step over, step into my code, step out of, and what's this last one? Run to cursor. Okay. The big ones here are probably going to be like step into or step over. So when I say cur max A-list, I'm going to hit step over. Great. It ran that one line of code and it currently tells me the values of everything at that one line after we executed that line. So do it again. Okay, do it again. Okay, do it again. Do it again. All right, I guess we didn't flip the condition. Do it again. C is now 1. Oh, okay, well, this gets evaluated true, so we run that, go there, run that. So now you can actually see what your code is doing, what lines of code are actually running at what point in time in the execution of your algorithm. It's pretty cool. Now, there's the other one, step over, step into, and step into my code. The trouble is, if I said like, okay, let's see. Okay, let's try this again. Okay. If I do step into, it'll still do the steps, but if I say step into and the line of code is a function call, it'll go to the code in that function, which is cool. Unless you say step into print, I guess it skips it. Oh, okay, well that's handy. If I'm using a whole bunch of libraries, like NumPy or something, and I call some crazy sign evaluation or something, and I say step into, it's going to step into the code that someone else wrote that's probably going to confuse me and there's no problem there. So I might be careful saying step into. There's also an option, step into my code, that will basically skip anything that already exists. It'll only step into the function call to a function that you wrote, which is handy. Again, this is not something that you need to memorize. Step out of, that's like if you're in a function call and you're like, okay, I don't care about this, step out. And it goes back to the calling function. So, you know what, let me show you an example. So, let's say stop. And then, oh, does it not have NumPy? Okay. And then, okay, what's it mad about here? Okay, okay, cool. So, and then down here, I'll say, this is a silly function, and then I'll also say, print sign of 55. Rather silly code. Okay, so let's start debugging. Okay, I'm going to say step into. So if I do step into, so now I'm on this line of code, but this is a function call. So if I say step into, there, we go to that function. And then we see that, okay, great, we go here. Now I get to this line, step into, oh, I guess it's smart enough not to go into these big packages. Well, whatever, the spirit of this is, there's a difference. Let's not worry about it too much, because I guess it's getting smarter and smarter every year. If, however, I'll show you the step out of real quick. If I'm running and I do, okay, step, 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 and I get here and I'm like, you know what, I don't care, just step out. There, it just goes to where that function was called. Now, there's one last thing I want to show you, which is pretty neat. Step into, step into. Okay. So, at the back, I'm guessing you can't read this. You can barely read it? The good news is there's a lot of seats down here. So if you're having a hard time seeing stuff, totally move up. No. See if I can, see, print screen maybe. What? There we go. Okay. Pardon me while I try to figure out how to zoom in. Okay. Do you see this? Can you see it now? Yeah, okay. So here's what we are now seeing. This is interesting. Because I wrote a function, right, called find max index. And then that function actually called another function. This is a silly function. Okay? And then I had code running down here as well. So I was like, my code called a function that also called a function. So I was kind of like two functions deep, right? What this is showing me is where I am in the code. So it shows me, if we go here, on line 27, which is the line that called the function find max index, we went into this function, find max index, and then on line 13, right here, we called this is a silly function. So this is a silly function is called. And then on line 4, well, that's where we had stopped. right there. This is what we call the call stack. This is where your program is, because your program's running, and then it calls a function. It's like, okay, all right, well, I'm going to hit pause, because I'm going to need to resume running this function. But before I do, I got to go run this function and finish it. Great, so now I have this function. And I come across another function call. Okay, great. I need to remember, though, information about this function, put it over here, and then call the other function, and then let that one finish, and so on and so on and so on. So this is the call stack, and this is very, 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 very important. It tells us where we are. And what's kind of neat, too, is I'm trying to think of a good example. Have you ever been like telling a story, and then you go on a tangent, and then you go on another tangent, and then maybe another tangent, but you kind of have to backtrack, right? Like I'd start telling you a story about my friend Bob that went to the swimming pool. Okay? But you know what? We got to tell you a little bit about the swimming pool first. And then we got to tell you a little bit about what the weather was like that day. And then once I finish telling you about the weather, I can continue telling you about the swimming pool. And then once I finish telling you about the swimming pool, I can finally get back to telling you about the story about Bob that went to the swimming pool, right? It's kind of like that. You do this all the time in your everyday. You just don't really think about it. The computer's keeping track of it too. It keeps track of where it was. It knows it needs to resume where it was. Keep going forward. Keep running those functions. And then when they finish, we can go back to where we were so we can pick up where we left off. Okay, any questions about that? No questions or anything? Bless you. Okay, now, getting data into Python. You've done this a bunch already. You did it for assignment 2. Wait, no you didn't. You did it for assignment 1, which is great. We read in a file. Now, you didn't have to write that code, but of course, the first part of that assignment was to read the code that already existed and try to get a sense of what it was. And despite never seeing this before, who wants to take a wild guess as to what this line of code would do? Exactly. Who would have thought, right? Open the file called a file name.txt. Anyone want to take a wild guess what the R means? Wait, someone said something here. Read? Yeah, that's exactly what it means. Open it in read mode. So I'm going to read from this file. Great. There's write mode as well. You can write to files. You can do both, whatever. But yeah, here's how we open up a file. I'll warn you though, not many programming languages make opening a text file and reading from it, or any file and reading from it, that trivial. It's not hard, it's just in Python it's really easy, which is cool. So here's what we're going to do. Here's an activity. Create a text file in the working directory, and if you're using Colab, there's a bit of a to-do here. And I'm going to show you. I'm going to create a new text file. Maybe I won't. There. I'm creating a text file. This is a really simple little text file. Just some lines in there, whatever. I'm going to save it. I'll save it to my desktop. Call it a text file.txt. Okay, great. There it is. You can even see it on my desktop. I put it on my desktop. So far, so good? So if I go to Colab, which I guess I'll need to open up now. The trick with the text file, if you want to open it, you need to tell the computer where that file is in order to open it. If I say open a text file, like Python will be like, okay, well, where the hell is it? It'll only work if you just say the file name if the file is in Python's working directory. Basically, where is the program being run from? long story short, what I can do is I go here, files, no, allocating, yeah. If I'm on Colab, if it'll finish allocating. Looks like we broke Colab right now. You think it's just the way it could be? Okay, let's try refreshing. Well, remember how you uploaded files for assignment 1? You had to upload the starbucks.csv. It's the same thing. You're going to do that, but here. Print. Hi. Okay, great. Okay, it's connected. So here, I'm going to upload a file from my desktop, a text file, open. Reminder, uploaded files, yeah. Okay, great. It exists. And it's cool because I can actually click it and it'll show me what's in there, which is kind of neat. So I'm going to go back to the code, take this. Nope, I was using Colab. Except, of course, I changed the name to a text file. There. And run. Okay, great. Let's see what happens if we do this. My file and type file. Oof, a lot of information there. So it looks like if I print out the file, it tells me this IO, text IO wrapper name, a text file.txt mode R, encoding UTF-8. There's a lot of information there. All it's telling you is some high-level information about the file you loaded up. So do the rest of this activity. Upload some text file, put whatever data you want in there, and then open it and try using some methods. Read lines and whatnot. If you remember, we can see dot, and we can see all these things. Close, detach, errors, file no, flush, is addy, name, new lines, readable, and so on. Try playing around with some of them and just see what happens. Best way to learn this stuff is to poke around and see what happens. All right, seeing nobody actually doing it, I'll just show you some stuff. See what happens. Let's call read and see what happens. Print data. Oh, looks like read just read in everything. Who's surprised by that? Probably no one. Okay, let's try read line. Well, I'm not going to print this out. There's nothing going on here. When I try to print out read line, it doesn't work. Does anyone have any? Yeah, you got a question? No, that's not the problem, but I like what you're thinking. This isn't working when I try to read the line. Does anyone have any idea why? Yeah, I didn't think so. The trouble is, when you read a file, the file knows where it currently is. And when you tell it to read a line, it'll read that line and then wait at the front of the next line. If you read everything, it'll read everything and then go to the end, and then we're done. The file's done. You can't read a line anymore because there's nothing left to read. Let me show you with this first. I'm going to do read line here. I'm going to print it out. And then I'm going to do my file read line again and then print it out. So now we see data. And then when I said read line again, it automatically just did the next line for me. I can keep doing this over and over. Into, I guess we got to do another one. Another one. File. So this is the whole contents of the file. And then if I try to do it again, there's nothing more to happen. So I'm stuck. Once I take like a step through that file, I can't go back. When I did read, I stepped all the way through the file, and then I couldn't go back. So if I ever wanted to read again, I'd have to reopen up the file. I'm stuck. I got to start all over. And that's no big deal. I can just do that. All right, so let's just do it again. Great. Did it again. So no worries, but just be warned about that. Any other questions about that? See if you can figure out how to write to a file. Try that right now. And I give you a starting point. And of course, we put a W here. Anyone want to take a wild guess what W means? Hey, makes sense. You know what's really cool too is this file wasn't there a second ago, but I wrote this line of code, open a file called another file name.txt in write mode, and then it popped up in my my folder there because I just created that file. I'll delete it and prove it to you. Delete. Okay, yes. So I'm going to refresh to There is no file in there called another file name. Do you agree? Of course you do. I'm going to hit run. Now I'm going to go refresh. Oh, and there it is. I mean, there shouldn't be anything in it. In fact, there isn't. There's nothing there. But it exists now, which is cool. The program made that file. Pardon?
Can you put any file extension instead of .txt?
File extensions are probably a lot less helpful than you think they are. I can put blah, 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 blah. Run it, refresh, it exists, and I can still open it. It's just the file extensions are really only like hints to your computer to know what program to open it with. You can open up any file, though, as like a text file if you want. In fact, let's do that real quick here for fun. This was the screenshot I took earlier. Let's open with another application. No. Let's do this. New window. Perfect. Oh, come on. Let me open it. Oh, it may be trying, and now it's just angry at me. Okay, it's trying to, and the text editor has become very angry. Whoop. Yeah, there we go. See, we just opened up that image as a text file. It's not very helpful, but it is. So when it sees like .png, it's going to go, oh, that's a picture. So I know I should open .png files with a picture. If it's a .txt, I should open it with that. But in reality, it doesn't really matter what they are. Anyways. Little trivia, but yeah, we can create it with whatever extension we want. It's just that it doesn't even really matter. If you're on Windows, however, I will warn you, raise your hand if you're using a Windows computer, really high. Okay, I'm going to give you a warning. By default, Windows likes to hide common file format extensions. Okay? This will be the bane of a programmer's existence. I highly recommend you change that. Don't ask me how, because I forget it every other day. Every time I need to do it, I just go to Google and say, show file extensions. And then there's like you right click on a Windows properties something. But I highly recommend you turn off the feature of hide common extensions. Because the number of times you will look at a file that says like hello world, or in this case, a text file. Because it's .txt, Windows won't show you .txt because it's a common file format, right? So when you look at it, you're like, oh, the file name is a text file, but it's really a text file.txt. So you try to open up the file called a text file, and it's going to say, well, that doesn't exist because Windows was hiding it because it's trying to be helpful. Except in reality, it just pissed you off because it hid it. And then another big problem is you're like, oh, well, I know the problem. I can see the problem. It's because it's not a .txt. So you go to that file, and then you add a .txt because you don't see the .txt, but it's there secretly. And then you do, oh, well, I'm just going to rename it to .txt. But this last one's hidden from you. So now you've got a file called a text file.txt.txt that you're trying to open as a file.txt, but there is no file called a file.txt because it's called a file.txt.txt. Long story short, save yourself some pain and do this. Show hidden file extensions, windows, whatever. Perfect. Show hidden, no, not files. I want file extensions. There, do this. There you go. I highly recommend you do it if you're on Windows and you will continue programming at all. Because this will get you, it's gotten me a bunch of times. So, did anyone raise your hand if you wrote to the file. One person, two people? Okay. All right, well, we'll end here then, I guess. Figure out how to write to files, though.